Here is a tomato. Large even, bright red. It looks like it was painted. A perfect circle. A perfect color. It looks like a tomato from a pizza advertisement, and if you eat it right now, you will most likely feel nothing. Literally nothing. A little acidity, a little water. Maybe the smell of cucumber, but not tomato. The tomato exists. The taste does not. And that is not your fault, and not a bad batch. This is a system. A well-tuned, carefully built system that killed the taste of the tomato and replaced it with appearance. Today, I will tell you exactly how this happened, when, who made that decision, and why it is still in effect, despite everyone knowing about it. Well, first, a brief geography to understand the scale. The tomato is the most popular vegetable in the world. In the United States, about 12 million tons are consumed every year. On average, more than 20 kilograms per person per year. That is pizza, pasta, sauces, salsa, ketchup, sandwiches, and of course, simply a sliced tomato on a plate. At the same time, most Americans surveyed by scientists from the University of Florida say the same thing. Supermarket tomatoes are tasteless, not like they used to be, not like at grandma's garden, not like at the summer market. And here is where it gets most interesting, because this is not nostalgia, not a memory error, not the grass was greener back then. This is a fact confirmed by chemical analysis. Tomatoes have truly changed, and scientists know when, how, and why. But to understand this, you first need to figure out what the taste of a tomato actually is, because it is more complex than it seems. The taste of a tomato is not one substance. It is a symphony of several hundred chemical compounds acting simultaneously. Scientists have identified more than 400 volatile compounds that form the aroma of a tomato, but the key ones number around 30. Among them, cis-3-hexanol, that very smell of fresh green leaves and a garden bed. Geranyl-acetone, a floral, slightly sweet note. Beta-ionone, a woody, deep aroma. And guaiacol, a smoky, warm, almost vanilla aftertaste that you feel after you have already swallowed. These compounds are volatile, meaning they literally evaporate and reach your nose. That is how the brain reads aroma, and taste and aroma are 80% the same thing. What you feel on your tongue is only sweet, sour umami. The rest is the nose. Now an important point. These volatile compounds form during the ripening process, right on the vine, under the sun, and this requires time and a specific temperature. And here is the first break. In the 1940s, American agriculture began to scale. Supermarkets appeared, cold chain logistics appeared, refrigerated trucks appeared, and tomato producers faced a challenge: how to deliver a tomato from Florida or California to New York or Chicago, alive. A soft, ripe tomato does not survive transport. It cracks, rots, turns to mush in 2 to 3 days. So the idea emerged. Harvest tomatoes before they ripen, green or pale pink. In that state, they are as hard as apples. They survive the journey. They sit on the shelf for a week, and then, already in a distribution center or right in a supermarket warehouse, they are treated with gas. Ethylene. It is exactly this that triggers the ripening process in fruits and vegetables. The tomato turns red, becomes softer, looks ready. But there is one problem. Those same aromatic compounds, cis-3-hexanol, geranyl-acetone, beta-ionone, form only when the tomato ripens on the vine, in natural conditions, under the sun, when the entire plant is still alive and pumping sugars, acids, and esters into the fruit. In a refrigerator and under the influence of artificial ethylene, this process does not start. The tomato reddens on the outside, but remains empty on the inside, without taste, without aroma. This was known as early as the 1950s, but the system was already running, and it worked. The tomato sold. The consumer bought. Nobody particularly complained out loud. In the 1960s and 70s, universities joined in on solving the tomato problem, but they framed it not as you might expect. The task was stated as follows: breed a variety that withstands mechanical harvesting, long storage, and transportation over thousands of kilometers. Not a word about taste in the technical specifications. This is not an exaggeration. This is a documented fact from the archives of American agricultural universities. The result appeared in the 1960s. The first commercial variety with a tough skin and standard dimensions, VF 145, then entire lines, Celebrity, Beefsteak, the firm version, various F1 hybrids designed for industrial cultivation. Each new variety, a little firmer, a little more uniform, a little longer shelf life, and with each generation, a little fewer of those same aromatic compounds. Scientists even found an explanation for this at the genetic level. In 2012, an international group of researchers published a large-scale study in the journal Science. They analyzed the genome of more than 200 tomato varieties and found that in the process of commercial selection, the genes responsible for the synthesis of sugars and aromatic compounds had effectively dropped out of the plant. One specific gene, TDR20, regulates the accumulation of fructose and glucose in the fruit. In wild tomatoes and old garden varieties, it is active. In most commercial hybrids, it is suppressed or absent. This is not a hypothesis. This is measurement, chromatography, genomic analysis, comparative tasting panels. Taste was bred out of the tomato, not intentionally as a crime, but quite consciously as a compromise. And that compromise was not agreed upon with you. But there is one more factor, and it is perhaps the simplest, and the most terrible: cold. Tomatoes cannot be stored in a refrigerator. Everyone who has ever read about cooking knows this, but most supermarkets keep tomatoes at a temperature of +4 to +7 degrees Celsius, exactly as much as in a regular household refrigerator. In 2016, scientists from the University of Florida conducted a simple but harsh experiment. They took ripe tomatoes with good flavor from a farmer's market and placed some of them in a refrigerator for 1, 3, and 7 days. The rest were kept at room temperature. The result? After just 1 day in the refrigerator, the level of key aromatic compounds dropped by 65%. After 3 days, by 85%. After 7, almost complete loss of aroma. The mechanism is this: cold shuts off the enzymes that produce volatile compounds, and, importantly, this process is irreversible. Even if you take a tomato out of the refrigerator and leave it at room temperature for a day, the taste will not return. The enzymes will no longer start up. That means even if a producer grew a flavorful variety and harvested it ripe, the supermarket storage system would kill the taste before the tomato ever reached you. 3 blows, a variety without aroma, harvesting before ripening, cold storage. Each subsequent one finishes off what was left after the previous one. And now, the part that turns the whole picture upside down. In 2017, scientists from that same University of Florida, Harry Klee and his team, published a study in the journal Science that revolutionized the topic of tomatoes. They did not just conduct a chemical analysis. They connected chemistry with the taste perception of living people. The group conducted tasting tests with hundreds of participants. Simultaneously, a detailed chemical analysis of those same tomatoes, and established an exact list of 28 compounds that determine whether a tomato tastes good to people, not theoretically, but actually in the mouth. Among those 28, 13 aromatic volatile compounds, 8 sugars and acids, and 7 other metabolites. And almost all of them are catastrophically scarce in commercial varieties. But the main conclusion was this: restoring taste is achievable. The genes responsible for it exist. They are simply switched off or displaced during the selection process. They can be returned, without GMOs, using only traditional hybridization. And here is the moment when everything should have changed. After the study was published, it was discussed by everyone: journalists, farmers, culinary bloggers, agronomists. Tomato producers also knew. Seed companies, too. And what changed? Almost nothing, because transitioning to a new variety is not simply planting different seeds. It means rewriting contracts with supermarkets, changing quality standards, reconfiguring logistics, convincing buyers that a new tomato that looks slightly different will still be purchased. The system does not want to take risks. The system is already optimized, and it sells. Perhaps tasteless, but it sells. And here a truly controversial idea appears, expressed by some economists who study food markets. The problem is not with the producers. The problem is with us. We buy with our eyes. We pay for size and color. We do not return a tomato to the store with a note saying, "It does not smell." We simply buy the same one again next time. And the market receives the signal, "Everything is fine. Keep going." So, the conclusion. The tomato in the supermarket is tasteless not because of chemistry, not because of GMOs, not because of climate. Taste is chemistry. These are specific molecules that form under specific conditions. And those conditions were sacrificed to three things: transportability, shelf life, and appearance. The first blow, the variety. Genes responsible for sugars and aroma were selectively bred out of the tomato because they interfered with firmness and uniformity of the fruit. The second blow, harvesting before ripening. The tomato travels to you green and ripens along the way under artificial gas. Aromatic compounds do not form this way. The third blow, cold storage. Even if by some miracle a tomato arrived at the store alive, the refrigerator shuts off the aroma enzymes permanently, irreversibly. The solution exists. Scientists found it back in 2017. A tasty tomato that withstands transportation has already been developed in individual laboratories. But between the laboratory and the supermarket, there is an entire system that currently has no interest in changing anything. And now, the practical part. If you want to find the real taste of a tomato, here is what actually works. First, look for small and ugly ones. Market tomatoes, small cherry varieties from local farmers, cracked side tomatoes, are often far more aromatic than the uniform red giants in the store. Second, never put them in the refrigerator, even if you bought them sliced, even if it is hot. Cold kills the taste and does not bring it back. Store at room temperature, eat within a day or two. Third, smell before buying. A real tomato smells, even through the skin. If you are holding a tomato and feel nothing, it will have nothing to offer on the plate either. Fourth, try to find old or heirloom varieties. Brandywine, Cherokee Purple, Green Zebra, they are ugly, they spoil quickly, they are more expensive. But they have taste, the one you remember or are looking for. The market sells you beauty. Taste you have to find yourself and with a little more attention and a little less trust in the perfect color. And next week, another product whose taste was stolen. And there, a completely different reason. Not logistics, not selection. There, it is the attention economy and marketing that changed what you considered delicious. Hint, you most likely ate this product this morning. Subscribe so you do not miss it. Leave a like if today you will look at a tomato in the store differently. And write in the comments, do you feel the difference between a market tomato and a supermarket one? Or is it just memory?